For the first of our Chapter 5 concept check questions, you're asked to draw the enantiomer of the molecule shown. Anytime we want to draw an enantiomer, all we have to do is draw the mirror image. And I can draw the mirror image in two different ways, so I'll show you both ways here. First, I can imagine a mirror on the side of the molecule, and then draw the reflection of the molecule from left to right. To make sure that what I draw really is the enantiomer, I can assign the R and S configurations to both structures. Here the structure on the left is the S enantiomer, and the structure on the right is the R enantiomer. The other way I can draw the enantiomer is to imagine the mirror in front of the page or the screen, and then draw the reflection about the page. That means that everything in the plane of the paper stays the same, and I simply invert wedges and dashes. So the chlorine becomes a dash. Again, I should check to make sure that what I've drawn is the enantiomer. The priorities stay the same, and if I reorient this so that the hydrogen is pointing back, I'll find that the stereochemistry is in fact R here. In this question, you're asked to determine the numbering priority for the molecule shown, and then assign it as R or S. To determine the priorities, I always start by looking at the 4 atoms bound directly to the chiral center. Here I have 2 carbons, an oxygen, and a sulfur. The sulfur is the highest priority. Remember, this goes by atomic number. Then the alcohol. For the last 2 groups, which both have a carbon attached to the central carbon, I need to move 1 carbon over. So then I'm comparing a hydrogen and a carbon. So the ethyl group is priority 3, and in this structure, the methyl group is the lowest priority. That means I want to orient the structure so that the methyl group is pointing backward. That places the OH group to the right, the SH group down, and the ethyl group to the left. I add the priorities to the drawing, and then I draw a curved arrow from 1 to 2 to 3, and I find that the arrow is a clockwise arrow, so this chiral center has the S designation. In this concept check question, you're asked to draw a structure, including the stereochemistry, from the name, R2-chlorobutane. I'll always start by drawing the structure without stereochemistry. Then I'll identify the chiral carbon, the carbon with 4 different groups on it, and then I'll rank those 4 groups. Here chlorine has the highest priority, the ethyl group is second, the methyl group is third, and the hydrogen is last. The R designation tells me that I need to orient my groups with priorities proceeding in the clockwise direction. So I'll draw a Newman projection down the carbon-hydrogen bond, and then I'll add the groups, starting with the chlorine, and proceeding in priority order clockwise around the carbon. Then I need to convert this Newman projection-like drawing into a line drawing. So I next identify the chain, and I'll indicate that here in black. Okay. Then I draw the chain in the form of a skeletal line drawing. For this example, that just means I'm tilting the drawing or rotating it slightly. And when I place the 2 groups on that chiral carbon, I'll be sure to keep the hydrogen back and the chlorine pointing forward. And finally, I like to redraw my structures as clean and proper skeletal line drawings, where the hydrogens are omitted and all of the carbons are indicated with only vertices and endpoints of the lines.